For this problem, we're given with the following data na meron tayong rectangular beam which is a wooden beam, so made of wood. And then it's a simply supported beam with a single concentrated load of 600 pounds. So we have a pin support at A and roller support at B. So dimensions are also given. You have the modulus of elasticity E, which is equal to 1.5 times 10 to the 3 KSI. So the dimensions of the cross-section are given. So 3 by 6, it's a prismatic beam again. So cross-section does not change. And then calculating the I, or the moment of inertia, we'll have base times height cube divided by 12, which is equal to 54 inch to the fourth. So ang required natin dito is to determine the Y max, or the maximum deflection within the or along the length of the beam. So again, ang first step natin is to draw the deflection curve or yung elastic curve. So Y max should be somewhere right here. From the neutral axis, tapos meron kang Y max. Ganyan. Okay. So medyo a bit different tong sample problem na to, no, compared sa sample problem natin kanina. Malalaman natin mamaya, no. So bali, ito yung sample problem na hindi lang boundary condition yung kailangan natin. Kailangan din natin ng tinatawag natin na continuity condition. So papakita natin yan mamaya-maya, no. So first, tapos na tayo sa step 1, which is to draw your elastic curve or your deflection diagram. Second is to find the moment equation, no? So para makuha natin yung moment equation, kailangan muna natin ng reaction. So ang reaction natin is meron tayong reaction sa A, meron din tayong reaction sa B. So we have RAY equals, diretso-diretsoin na natin, no? We have 600 times 4 divided by 12. So ito ay 200. So malamang ito ay 400 pounds. First na moment equation natin is dito, no? Gagawin natin sa function of x again. So moment as a function of x, kukunin natin. So mag-cut lang tayo ng section dito. Ganyan. And then we will consider the left portion. So magiging, meron tayong reaction dito na 200. Meron tayong shear, meron din tayong moment. So ito na yung moment as a function of x natin. So summation of moment, for example, dito sa section, so you will have moment function of x equals 200x. So substitute natin yung equation natin na EI d squared y over dx squared equals 200x. So first integration, you will have dy over dx equals 100x squared plus c1. Tama ba? And then you will have EI y equals, ito naman, i-integrate na naman to. You will have 100 divided by 3 x cubed plus c1x plus c2. Ngayon, like a previous example, gagamit na tayo ng boundary conditions. So boundary conditions, boundary condition natin first is that at x equals 0, kung saan yung pin connection, walang displacement. So walang displacement, so therefore y equals 0. So saan natin yan magagamit? Dito hindi natin yan pwede magamit, no, kasi hindi naman dy over dx yung given. So pwede natin siyang gamitin dito. So at x equals 0, magiging 0, magiging 0. Ang y daw is equals 0. Therefore, c2 equals 0. Ngayon, nakuha na natin itong C2 equals 0. Next na kukunin natin is yung C1. Ngayon, wala na tayong ibang boundary condition na available. Diba? Kasi, ito, wala naman to. Hindi natin magagamit ito kasi sa fixed support lang natin ito ma-identify agad na dy over dx or the slope equals 0. So, yun yung sinasabi natin na hindi enough yung boundary condition para ma-solve yung problem na to. So, kailangan natin ng continuity condition para ma-solve yung problem natin. So, paano natin yan gagawin? Kanina meron tayong beam, no? Na ganito. We have 200 and 400 na reaction, and we have 600. Ang gagawin natin dito, first, magagamit pa rin natin yung unang equation natin, no? Kaya lang, de-designate na natin siya as x1, tapos gagawa tayo ng isa pang equation dito, designate natin as x2. Ngayon, saan natin makukuha yung continuity equation? Di ba yung curve natin is ganito, no? Ngayon, gagawa natin ng mx or moment equation as a function of x2 hanggang dito sa point na ito, no, kung saan may concentrated load. Ang x1 naman, yung equation natin kanina is only applicable at up to this point. Bakit? Kasi pagdating mo dito, meron ng change ng ating loading. So, yung equation mo na 200x, bali ito, no? Yung moment equation mo na 200x, paglagpas mo dito, hindi na yun applicable yung 200x. Kasi meron ka ng 600 na loading. Pag dito naman na equation mo, for example, dito lang din siya applicable, meron ka na ulit ibang equation na applicable para sa the rest of the length of the beam. So, gawin natin na equation yan ngayon. Bale, ito na yung magiging section para sa x2. So, since papunta siya dun sa left, consider natin yung right portion. So, meron tayong shear, meron tayong moment. So, this is m sa function of x2. Ito ngayon ay x2. So, moment x2 as a function of x2 equals ito ay 400 pounds. Therefore, ang moment mo ay 400 x2. Diba? So, substitute natin yung equation natin na d squared y dx squared equals 400 x2. So, unang integration, we have ui dy over dx equals 200 x sub 2 squared plus, ngayon, gagawa tayo ng bagong variable c3 since nagamit na natin yung c1 at c2. ei naman times y equals 200 divided by 3 x2 cube plus c3 x sub 2 plus meron na tayong c4 ngayon. Okay, boundary equation din tayo sa equation or second moment na equation as a function of x sub 2 at x sub 2 equals 0. Syempre y mo din equals 0. So dito yan sa roller na support natin bale, no? So at x sub 2 equals 0, ito yung roller support na walang displacement, therefore displacement y equals 0. So, saan natin na ma-apply? Dito, no? Sa equation na to. So, we have 0, 0, 0. Therefore, C4 equals 0. So, meron na tayong dalawang constant na 0. We have the C2 yung kanina. C2 equals 0. And ngayon, meron na din tayong isang constant na na-identify. C4 equals 0. Ngayon, balik tayo sa continuity condition. Nabura pa natin yung drawing. Oops, hindi masyadong scaled. Dito banda, no? So, ito yung deflection natin. Since yung moment natin as a function of x sub 1 is applicable na siya hanggang dito, at saka yung moment natin as a function of x sub 2 is applicable na siya hanggang dito. No? So, ibig sabihin at x1 equals 8 and x sub 2 x sub 2 equals 4 feet. Dapat pareho sila ng y, di ba? Dapat pareho sila ng y dito. And then pareho din sila ng slope. Ngayon sa slope, medyo tricky itong part na ito, no? So, ibig sabihin, meron silang y1 equals y2. Sa slope naman, slope 1 equals negative of slope 2. Alam niyo kung bakit? Kasi pag titingnan natin dito, pag galing ka sa direction na to, itong slope na to ay positive. This is ito yung slope, no? Pag galing ka dito, papunta doon, ang slope na to ay positive kasi directed counterclockwise from the horizontal axis. Pag galing ka naman dito, sa x sub 2 na part, ang angle mo ay measured from dito. Di ba? Pero equivalent lang na angle yan, pero magkaibang direction. So, negative siya dito, dito naman ay positive. So, nagets niyo ba? Bali, again, no? Pag yung angle na nasa point na 600 pounds, pag galing ka dito, ang measurement ng angle mo ay pag ganito, no? That's a positive theta 1. Pero pag galing ka naman dito, ang magiging measurement ng angle mo ngayon is ito na, which is theta 2, na negative na ngayon, di ba? Nasa ilalim na siya ng ano. It's quadrant 4. So, it's negative. Ito naman positive. Ito naman negative. So, magiging negative. So, ito ay dy. Di ba ang slope natin is dy1 over dx1 equals dy2 over dx2 negative. So, ito na ngayon na yung bago nating continuity equation for displacement and continuity condition for slope. 100 x sub 1 squared plus c1 equals negative of 200 x sub 2 squared plus c3. Yun yung equation kanina. Tapos may negative sign. You will have an equation of c1 and c3. Evaluate lang natin. Ito ay magiging 108 squared plus c1 equals negative of 200 times 4 squared plus c3. So, evaluate lang natin yan. This is a bracket. Evaluate lang natin. Magkakaroon tayo ng c1 plus c3 equals, kasi may negative, so ilipat natin ng c1. You will have 100 times 8 squared times 8 squared minus 200 times 4 squared. 3 to 100. Tama ba? So, we have 100 times 8 squared minus or plus na, hindi na minus na kasi negative ma-plus mo pala. So, plus, sorry. 200 times 4 squared. 9600. So, bali ito, C1 magiging negative. Ito naman magiging negative. Tapos ito magiging negative. So, magiging negative 9600. Yan yung C1 plus C3 natin na equation. No? Equation 1 for C1 and C3. Next is evaluate natin itong Y1 tsaka Y2. So, you will have 100 divided by 3, yung equation natin kanina, x sub 1 cube plus C1 x sub 1. Yung C2 wala na, equal 0 kasi yun, di ba? So, you will have a positive na to, no? Hindi na negative. Sa slope yung may negative. 200 divided by 3 x sub 2 cube plus C3 x sub 2. So, ito yung para sa second na boundary condition natin na y1 equals y2. Kaya in-equate natin. So, this is y1, this is y2. Same with kanina, this is slope 1, slope 2. So, substitute natin 100 divided by 3 times 8 cube plus C1 times 8. Infinity na. 8 equals 200 divided by 3 times 8 cube plus C3 times, 4 pala to. Kasi x2 equals 4. Equals 4. Okay? So, evaluate lang natin. You will have negative 1600 plus 1/2 C3. And then you will substitute, this is equation 2. Substitute mo ngayon sa equation 1. You will have, so C3 equals negative 3.33 pounds foot squared, and then C1 equals negative 1600 plus negative 5333.33 divided by 2. You'll have negative 466.67 or 66 pa rin pounds foot square. So you will have 4266.66 divided by 100, square root of answer, x equals 6.532. 6.532 feet. Ang ingay ng aso. So, nakikita ba? 6.532 feet. So, ngayon, gagamitin natin yung x sub 1 value para makalculate yung maximum deflection gamit yung EI times y equals 100. Value natin for C1 and C3, yung C2 and C4 natin ay 0. So, meron na tayong equation ngayon. Kompleto na yung equation natin for moment as a function of x sub 1 and x sub 2. Ngayon, kukunin natin yung maximum na deflection using, since mangyayari siya before x equals 8 feet. Kasi pag ganito yung loading, nandito yung maximum mo, no? Before the, ito yung max, before the x equals 8. Pero para mas masiguro tayo, yung maximum na deflection natin is kung saan yung slope mo equals 0. Therefore, dy1 over dx1 equals 0. EI equals 100 x sub 1 squared plus C1. Kanina na. So, substitute na natin yung C1. You will have, and then dy, since ito yung after natin, is 100 x sub 1 squared plus C1 na negative. Diretso na lang natin, no? Negative na lang natin agad. You have negative 4266.66 equals 0. So, makukuha natin ngayon is yung x na value. So, saan matatagpuan yung maximum na deflection? So, dy1 over dx1 equals 0. Kasi sa maximum na deflection, 0 yung slope natin. So, this is slope 1. So, x sub 1 equals, minus natin agad ang C1, which is 4266.66 x sub 1 of y equals, evaluate natin yung x, no? 100 times 6.532 cube divided by 3 minus 4266.66 times 6.532. Ito ay divide natin sa 1 over EI. Kasi wait man natin yung sa taas, magiging 100 times 6.532 raised to the power of 3 divided by 3 minus 4, 2, 6.66 times 6.532. That's so y equals negative 18,579.8 divided by EI. So ang unit natin dito is pounds feet cube. No, kasi yung C1 natin is naka pounds feet square times feet, so feet cube. Ito naman ay naka x cube, so feet cube. So kailangan natin i-convert yung feet into inches. So ito times natin siya ng 12 cube. Tama ba? Tingin ko divided by yung 54 na I, tapos yung 1.5 times 10 to the 6 na kasi pounds natin equals 0.3. So y equals negative 0.396 inches. Therefore, ang deflection natin ay inches downward kasi mayroon tayong negative na symbol. So yun yung maximum natin na deflection sa ating given na simple beam. So salamat again sa pakikinig at sa panunod. Sana may natutunan kayo ulit. So tune in lang para sa next na sample problem natin for integration or double integration in solving slope and deflection in beams. So thank you again.